Section 3.1, Properties of Parallel Lines. In the diagram, I have line T. T is a transversal. That's a line that intersects two coplanar lines at two different points. Here, T intersects line M at a distinct point and line N at a distinct point. We know the intersection of two lines creates properties of angles that we already know about. For example, vertical angles, and also linear pairs for each intersection of T to M and T to N. In this section, what we want to do is identify different pairs of angles that has a relationship with T, M, and N. From previous sections, we already know how to identify vertical angles when two lines intersect and linear pairs when two lines intersect. Now we need to learn how to identify special angles when a line, being a transversal, intersects two other lines at two different points. Our first pair of points is called alternate interior angles. There are pairs of angles that are opposite sides of the transversal. Angle 1 and 4 are on the same side of my transversal. 3 and 2 are on the same side of the transversal, or 1 is opposite 3 and 2. Next, alternate interior angles are between the two intersected lines. Therefore, angles 1, 3, 2, and 4 qualify because they're inside of or between M and N. And the last part is they are non-adjacent. They can't be adjacent because 1 and 3 are on opposite sides of the transversal. They are in between my two lines, but we already know that 1 and 3 are a linear pair. Therefore, by the definition of alternate interior angles, opposite sides of the transversal, 1 and 2, in between the two lines, angle 1 and 2, and also non-adjacent, angle 1 and 2. That's our first pair of alternate interior angles. This has two pairs, angle 3 and angle 4. Also, a special quality about these pairs of angles formed by a transversal and two lines is that the transversal helps form both sets of special angles. For example, angle 1 is helped formed by T, and angle 2 is helped formed by T. Then 1 is formed by the other line, M, and 2 is formed by the other line, N. Our next special pair of angles created by a transversal when it intersecting two other lines is called alternate exterior angles. From the previous slide, I think we can identify these a lot easier because of the word exterior. And here, what we have is a pair of angles that are opposite sides of the transversal, exactly as it was on the previous slide. Therefore, 1 and 3 are opposite, 1 and 2 are opposite, 4 and 2 are opposite, 4 and 3 are opposite. They are not between the two lines. That is the exterior part. They are outside of my two lines being intersected by the transversal, and they are non-adjacent. Therefore, my alternate exterior angles that are in pairs are angle 1 and 2 are alternate exterior, and angle 3 and 4 are alternate exterior angles. If we go back to our first slide, alternate interior angles, I think we can see the name helps identify the pair of angles that we're trying to find. For example, alternate means opposite sides of the transversal, 1 and 2, 3 and 4. Interior, between my two intersected lines, M and N. Then we must always know that they are non-adjacent. Next, we want to alternate exterior, opposite sides of the transversal, outside my two intersected lines. Our next pair is same side interior angles. The same side will probably deal with the transversal. Interior means in between the two lines. So let's take a look at same side interior angles. Pairs of angles that are on the same side of the transversal. 1 and 2 are on the same side, 3 and 4 are on the same side. They're between the two lines. All sets of angles shown, 1, 2, 3, and 4, are all between M and N, the two lines being intersected by the transversal, and they are non-adjacent. Therefore, to identify my same side interior angles, I would have to choose angle 1 and 2 as a pair of same side interior angles, and angle 3 and 4 as a pair of same side interior angles. On the three previous slides, we identified alternate interior angles, alternate exterior angles, and same side interior angles. The names of those angles helped identify the angle in our diagram. Corresponding angles don't do that. Therefore, we strictly have to go by definition. Therefore, corresponding angles are pairs of angles that are on the same side of the transversal, but they are pairs that have one angle on the exterior of my two lines. They're outside M and N, and one is between M and N. But they still are non-adjacent. And with corresponding angles, I have 4 pair of corresponding angles. The other 3, alternate interior, alternate exterior, and same side interior, all have 2 pair. Here, when I identify my corresponding angles, 1 and 2, same side of the transversal, 1 outside, 1 inside, and non-adjacent. 3 and 4, 1 outside, 1 inside the 2 pair of lines, and they're on the same side of the transversal and non-adjacent. 5 and 6, 5, 6, same side of the transversal, 1 inside, 1 outside, and 7 and 8. Same side of the transversal, 1 inside, 1 outside. But as in our previous angles, all of our pairs are formed by the transversal. Therefore, if I just select one, 5 and 6, angle 5 and 6 are both formed by the transversal. Then are formed by M for angle 5 and N for angle 6. Therefore, the key to identifying any type of special angles formed by a transversal and 2 of the lines is to identify the transversal first, because they have to help form both pairs of angles. In our first example, they want me to name 2 lines and the transversal that help form each pair of angles, then name the pair. First, we're given angle 1 and 2. Angle 1 and 2. I'm just labeling with arcs so we can identify them in our diagram. First, of course, they want me to name the transversal. That's key. They have to have a line that forms both of them. And that line that helps form both angle 1 and 2 is line AC. The 2 other lines that help form angle 1 and 2 are line AD and BC. Now we want to identify the type of angle. They are on opposite sides of the transversal, and they're in between AD and BC. Therefore, they are known as alternate interior angles. Our next pair of angles, 3 and 4. We first have to identify the transversal, the line that helps form both of them, and also the line that intersects my other 2 lines. The line that helps form both of them is line BC. And we have to identify 2 other lines that help form 3 and 4. That would be line DC and AB. Now we want to identify the special pair of angles. We have angle 3 and 4 on the same side of the transversal. One angle is between my 2 lines. One is outside my 2 lines. Therefore, these are corresponding angles. Angle 1 and 4. First, can we identify a transversal? Is there one line that helps form both of them? I have AB help form angle 4. AB is just a line that intersects the vertex of angle 1. I could actually remove line AB and angle 1 would still be there. Angle 4 is also help formed by BC. BC is not part of angle 1 either. Angle 1 is formed by AC and AD. Therefore, there is not a common line that helps form either angle. Therefore, those are not special angles formed by a transversal. So we have none. There's no transversal. Therefore, I can't name the 2 other lines intersected by the transversal, and we do not have a special pair of angles. Angle ADC and angle DCB. I want to ignore segment AC because I want to deal with the entire angle DCB. First, let's see if we can identify a transversal. Line DC helps form both of those angles. Therefore, that is the transversal. The two other lines that help form those angles are line AD and line BC. Let's identify them. They're both on the same side of the transversal. They're both in between my two other intersected lines. Therefore, these are same side interior angles. Our next pair, 5 and 6. Here is 6. Here's angle 5. Let's see if we can identify a transversal. A line that helps form both of them would be line DC. That's our transversal. The two other lines that help form 5 and 6 are AD and BC. Let's identify them. They are on opposite sides of my transversal. And my two lines, AD and BC, these angles are outside of those two lines. Therefore, these are alternate for opposite sides of my transversal, exterior for outside my two intersected lines. Angle 5 and angle 3. From previous sections, I think we know that angle 5 and 3 are vertical angles. Therefore, they are not special pairs of angles formed by a transversal and two intersected lines from that transversal. These are formed by just two intersecting lines. The two intersected lines here are BC and DC. There is no third line. On this example, all they want me to do is classify each pair of angles. First, we're given angle 8 and 9. I'm going to put arcs in just to identify them. They are not congruent. The key to identifying special pair of angles with a transversal is to first identify the transversal. Here, line S is the transversal. Therefore, 8 and 9 are on opposite sides of the transversal, and they're inside my other two lines. Therefore, angle 8 and 9 are alternate interior angles. Angle 10 and 3. Again, we want to identify the transversal first. There is a transversal M. They're on the same side of that transversal. My other two lines, one is outside the other two lines, one is inside the other two lines. They are non-adjacent. Therefore, these are corresponding angles. Angle 1 and 4. Angle 1 and 4, we learned in previous sections. Angle 1 and 4 are vertical angles. Next, angle 5 and angle 3. Again, let's see if we can find a transversal. Here, my transversal would be line P. My other two lines would be N and M. Angle 3 and angle 5 are on opposite sides of the transversal. They're in between M and N, my other two lines. Therefore, angle 5 and 3 are alternate interior angles. Angle 6 and 14. Let's identify a transversal. The transversal is N. 6 and 14 are on the same side of the transversal. My other two lines are P and Q. They are in between P and Q. Therefore, they are same side interior angles. 11 and 13. Angle 11 and 13 have a transversal that is Q. They are on the same side of the transversal. The other two lines are S and N. One is outside those two lines, one is inside those two lines. Therefore, these are corresponding angles. Angle 2 and 6. Angle 2 and 6 have P as a transversal. The other two lines are N and M. They are on opposite sides of my transversal and are outside of my two lines. Therefore, these are alternate exterior angles. Angle 12 and 14. Angle 12 and 14, we know from previous sections as a linear pair.